The Pacific War opened with a shock when Japanese naval air power struck Pearl Harbor on 7 December 1941. Carrier air groups built around Mitsubishi, A6M Zeros B-5N torpedo bombers, and D-3A dive bombers showed that Japan could project force far from home waters. The Zero in particular impressed Allied observers. It combined long range for a carrier fighter, high agility, and was flown by elite pilots who had trained for years in pre-war programs. In the first months of 1942, the same formula worked in Malaya, the Philippines, and the Netherlands East Indies. A light hand-built fighter in the hands of an experienced aviator could outturn and outclimb many early Allied types. Japanese commanders read those victories as confirmation that carefully manufactured airframes, kept light, and flown by the best, would preserve their edge. Across the ocean, at Bethpage, Long Island, Grumman Aircraft Engineering Corporation was solving a different problem. The U.S. Navy needed aircraft that could survive brutal carrier operations day after day. Grumman's F-4F Wildcat was not the most agile fighter over the Pacific, but it was built thick, strong landing gear for slamming onto a pitching deck, corrosion-conscious construction for saltwater service, protected fuel tanks, and, crucially, parts made to standard Navy tolerances so that maintenance crews could swap components without guesswork. This was why the Navy called the place the Iron Works. It was an engineering system aimed at keeping aircraft flyable, not just spectacular in a test flight. Japan's early campaigns hid a structural weakness. To get the Zero's famous maneuverability, and range designers accepted light structure and minimal protection. That worked in 1941, early 1942, when Japan was on the offensive and operating from major bases. But Japanese aircraft factories at Mitsubishi and Nakajima depended heavily on skilled labor and did not produce the same volume of fully interchangeable spares that U.S. Navy logistics was beginning to move across the Pacific. Once operations pushed forward to places like Rabaul, air groups had to keep flying from airfields that did not have the full repair machine and spares infrastructure. A lightly built fighter that came back with combat damage or weather wear was harder to return to service quickly. By late 1942, around the Guadalcanal and Solomon's fighting, that difference started to matter. U.S. forces could take a battle-worn Wildcat, replace damaged panels or landing gear with factory-standard parts brought up by a growing logistics chain, and have the aircraft flying sorties again. Japan, fighting farther from its industrial base and already losing experienced pilots, could not regenerate aircraft and aviators at the same tempo. The decisive number was not just top speed or turn rate, but sortie rate. How many serviceable aircraft you could put up today, then tomorrow, then the day after. Grumman had designed for exactly that kind of war. Japanese industry had not. So the title holds, Japanese factories could not match Grumman once the war turned into an attrition contest. Japan began the Pacific War with superb handcrafted aircraft and elite pilots, but it lacked the deep, standardized, carrier-focused maintenance system that Grumman and the U.S. Navy were building from 1941 onward. When losses rose and operations lengthened, the Iron Works philosophy, rugged airframes, interchangeable parts built for repair design, crushed attrition. August 1942, Guadalcanal and the wider Solomons fighting turned the Pacific War into a test of who could keep aircraft flying every day, not just who had the more agile fighter. Henderson Field was muddy, exposed, and short on everything but U.S. Marine and Navy squadrons could still keep F-4F Wildcats in the air because those Grumman airframes had been built for carrier punishment and for part swapping under Navy standards. A wing or landing gear component could be replaced with stock brought forward by the growing U.S. logistics chain, and a pilot who brought home a shot-up Wildcat usually got his machine back in service. That was the Iron Works idea in action: rugged structure, protected systems and components, made to be replaced, not hand-fitted. The Japanese side was flying from far longer lines. Zeros, operating from Rabaul and other forward bases, could still make long overwater strikes, showing the type's exceptional range for a carrier fighter, and many of the aviators were still first-rate. But every long mission from a distant base consumed fuel, wore out lightly built airframes and brought aircraft back to fields that did not have full stocks of standardized spares. A Zero that took damage or simply accumulated fatigue could not always be turned around quickly. Japanese factories at Mitsubishi and Nakajima depended more on skilled labor and less on high-volume interchangeable parts, and as the campaign dragged on, that industrial model was harder to project forward into the Solomons. This is where the attrition story really appears. U.S. forces in 1942 could keep a corps of Wildcats flying off carriers and from Henderson because the aircraft were designed to be maintained. Japan could not regenerate damaged aircraft, and more importantly, could not regenerate veteran pilots at the same pace. Each experienced Japanese pilot lost over Guadalcanal represented years of pre-war training. Each American pilot who survived in a tougher Grumman fighter could learn fly again and add to the daily sortie count. When the F-6F Hellcat entered combat in 1943, it did not change the philosophy, it scaled it. The same Grumman carrier-minded design, reinforced gear protection, and factory-standard parts now sat on a more powerful, more competitive fighter and U.S. industry, including Eastern Aircraft's licensed production, could deliver them in numbers. That let U.S. carrier task forces maintain high repeatable sortie rates in 1,943-44. Japan by then was suffering from stretched supply lines, aluminum and alloy constraints, and a pilot pipeline that was getting thinner and less experienced. So the claim holds Japanese factories could not match Grumman once the air war became a sustained Pacific slog. Japan started with superb light handcrafted fighters and elite crews, but the U.S. Navy and Grumman had built for repair, interchangeability, and long campaigns. In the Solomons and afterward, that ironworks reliability is what crushed attrition. September 1,943 inches, the Central Pacific buildup toward the Gilbert's U.S. Navy fast carriers began to show what a fully industrialized, maintenance-first fighter design could do. The new Grumman F-6F Hellcat, operating from Essex-class and other fleet carriers, was built from the start for deck abuse, strong, wide-track landing gear, self-sealing tanks, armor for the pilot, and airframe sections made to Navy dimensional standards. That meant a Hellcat that came back with flak or fighter damage could be patched and turned around quickly using the same parts that Navy supply ships were carrying forward. This was the Bethpage Ironworks philosophy at scale, designed so that the fleet can keep the airplane flying. On the Japanese side, the naval air arm that had been bled in the Solomons now had to defend wider ocean approaches with fewer experienced pilots and more worn airframes. The Mitsubishi A6M Zero still offered unusually long range for a carrier-type fighter, and it could be staged through bases such as Truk, but its light structure and limited protection made sustained operations harder once damage and fatigue accumulated. Japanese naval aviation depended more on skilled handwork and less on the kind of high-volume, fully interchangeable spares the U.S. was now pushing across the Pacific. At forward bases, if the exact part was not on hand, a damaged Zero might sit, and every day it sat the available Japanese strength over the Gilberts and Marshalls thinned. When U.S. carriers supported the assault on the Gilbert Islands in November 1943, the difference became visible. U.S. task forces could launch repeated Hellcat strikes to sweep the airspace and cover the landings, then recover, repair, and relaunch because the aircraft were built to be maintained aboard ship. Sortie rates stayed high, not because every airplane could magically fly 3 times a day forever, but because the system, rugged airframe, standardized parts, trained carrier maintenance crews, and a deep logistics chain kept most of the fort. Air group serviceable day after day. Japanese responses, by contrast, were thinner and more sporadic, flown increasingly by less seasoned pilots in aircraft that were harder to keep in frontline condition, so far from the home factories. By late 1943, industrial depth was deciding the air fight. Grumman, reinforced by Eastern Aircraft's license production, could keep sending Hellcats and spares into the fleet, and the U.S. Navy's training pipeline was now producing enough carrier pilots who could survive in the forgiving Hellcat and gain combat experience. Japanese naval aviation, strained by shipping losses and material shortages, could not match that tempo, and dispersal of production later in the war only made standardization harder. The metric that mattered was not the Zero's theoretical long range, but how many fighters each side could keep mission-ready in the Central Pacific every day. On that metric, Japanese factories could not match Grumman. The ironworks' reliability is what crushed attrition. June, 1,944 inches, the Marianas Campaign, and the Battle of the Philippine Sea U.S. carrier air power finally exposed the limits of Japan's wartime aviation industry. Task Force 58 could put hundreds of F-6F Hellcats into the air because those aircraft were designed from Bethpage as carrier machines that could be repaired fast and reinforced gear for constant deck landings, self-sealing tanks, armor, for the pilot and airframe sections built to Navy standards, so damaged parts could be swapped using the spares carried forward by the logistics fleet. This was the ironworks philosophy in combat form. Build it so the fleet can keep it flying. Japan came into June 1944 with a naval air arm that was already worn down by the Solomons, the Gilberts, and Central Pacific losses. The Mitsubishi A6M Zero still offered long range for a carrier fighter, but by 1944, many of the pilots flying it were hastily trained replacements, not the pre-war elite. Light construction, which had been an advantage in 1941-42, now meant aircraft did not absorb damage well and were harder to keep serviceable at forward bases that lacked uniform spares. Japanese production had also been pushed into smaller dispersed plants, which protected it from sudden loss but made standardization and high-quality output harder. That meant fewer fully ready aircraft could actually be put in the air over the Marianas. When the Battle of the Philippine Sea began on 1920 June 1944, the imbalance was obvious. U.S. carriers could launch, recover, repair, and relaunch Hellcats for combat air patrol and strike escort because the aircraft and the supply system were built for that exact cycle. Japanese carriers and shore-based units, by contrast, sent up largely inexperienced aviators in light Zeros that could not take much punishment and that could not be quickly replaced once lost. The result was the so-called Great Marianas Turkey Shoot, in which U.S. fighters and shipboard anti-aircraft fire destroyed a large part of Japan's remaining naval air strength in a single operation. Seen from the Japanese side, the cause was not only pilot quality, it was that U.S. industry and Grumman's repair-friendly design kept putting full-strength air groups into battle, while Japanese industry, strained by materials, dispersal, and long supply lines, could not keep up. The number that decided the campaign was how many fighters each side could keep mission-ready over several days, not the Zero's theoretical long range. On that metric, Japanese factories could not match Grumman. Ironworks reliability is what crushed attrition. June, 1,944 inches. The Marianas was the moment when design for maintenance and industrial depth beat hand-built aviation once and for all. U.S. Task Force 58 entered the campaign with carrier air groups centered on the Grumman F-6F Hellcat, an aircraft conceived from day one to live on a carrier deck and to come back damaged, be repaired fast, and fly again. The Hellcat had reinforced wide-stance landing gear for constant arrested landings, self-sealing fuel tanks, armor protection for the pilot and vital areas, and most importantly, airframe sections and components manufactured to U.S. Navy standards. That meant a flight deck or hangar deck crew could remove a shot-up panel, a bent gear component, or a cowling, and replace it with parts coming from the fleet supply train without hand-fitting. This was the Bethpage Ironworks philosophy: do the hard precision work in the factory so the ship can do the quick work at sea. In a multi-day operation like the Marianas and the Battle of the Philippine Sea, that alone was a force multiplier because it kept the number of flyable Hellcats high even after heavy air action. Japan, by contrast, came to June 1944 with a naval air arm that was already in deficit. The Mitsubishi A6M Zero still had very good range for a carrier-type fighter, but that advantage was now largely theoretical. The air groups were no longer filled with 1,941-42 elite pilots. Repeated losses in the Solomons, Gilberts, and Central Pacific had forced the Japanese to send out much less experienced aviators. Those pilots were flying aircraft that had been designed light, with minimal protection, and that were never meant to be turned around rapidly on forward bases, short of standardized spares. Wartime dispersal of Japanese aircraft production into smaller workshops, combined with shortages of high-grade materials and the strain on shipping, made it harder to deliver uniform parts in quantity to frontline islands. So even before the battle started, Japan's ability to put serviceable aircraft into the air over the Marianas was weaker than the raw design of the Zero would suggest. Once operations opened, the U.S. system showed its full shape. Task Force 58 could launch large fighter sweeps and combat air patrols, recover aircraft, repair battle damage on board, using parts drawn from a supply system that had been planned months in advance, and then launch again. The same. You do not have to claim an unrealistically fixed 3 sorties per aircraft per day to make the point. What mattered is that the U.S. Navy could sustain a high repeatable tempo across several days because the aircraft were built to be maintained and the parts actually existed in the theater. That tempo kept radar pickets and the fleet covered, and it ensured that when Japanese raids came in on 1920 June 1944, there were enough Hellcats in the air and ready to launch to meet them. On the Japanese side, the same thing could not be done. The carriers and land-based elements of the combined fleet air arm committed to the battle had to fly with what they had. Aircraft that took damage were not always repairable quickly because exact replacement parts were not at hand. Every damaged or worn Zero that could not be returned to service immediately reduced the defending strength. Every novice pilot shot down was irreplaceable in the short term because the training system had already been shortened to fill squadrons. The underlying industrial problem was now visible in combat form. Japan had designed excellent agile aircraft for 1941-42 conditions, but it had not built the factory to fleet maintenance pipeline needed for a 1944 carrier war fought thousands of miles from the home islands. The result was the Battle of the Philippine Sea that U.S. sources later called the Great Marianas Turkey Shoot. Hellcats, backed by powerful shipboard anti-aircraft fire and good fighter direction, shot down a large portion of the remaining Japanese naval air strength in a single operation. U.S. air groups, because they were flying rugged, standardized Grumman fighters, could absorb losses and damage and still present strong decks on the following days. Japanese air groups, because they were flying light aircraft maintained by an overstretched and undersupplied system, could not. From the Japanese point of view, it looked like the Americans could keep filling the sky with fighters, while every Japanese loss was permanent. That is exactly what your title claims. Japanese factories couldn't match Grumman. Iron Works reliability. Crushed. Attrition is not just a slogan for 1941-42. It is what the Marianas in June 1944 actually demonstrated. Grumman and the U.S. Navy had aligned design, production standardization, and logistics so that a carrier task force could keep aircraft flying in a multi-day high-intensity operation. Japan, after 2 years of cumulative losses and with production dispersed and materials short, could not feed its frontline units with enough uniform repairable aircraft or fully trained pilots. When the air battle turned from a duel of individual aircraft to a contest of how many fighters you can keep mission-ready over several days, the American Iron Works model won, and the Japanese model broke. January 1945 marked the point where U.S. fast carrier task forces could operate almost at will, while Japan no longer had an air arm that could answer. By this stage of the war, the U.S. Navy was flying Grumman F-6F Hellcats that had been built from the beginning to live on carriers, take damage, and be put back on the flight schedule. The airframes had self-sealing tanks, armor, and carrier-strength landing gear, but the real advantage was standardization parts coming from Bethpage and from Eastern Aircraft matched what maintenance crews on the hangar deck expected to see. A Hellcat that came back with flak holes or a damaged panel could be stripped and refitted using the same pattern of spares the fleet train was delivering across the Pacific. That kept availability high over several days of strikes. At the same time, Japan's aviation base was collapsing. 29 seconds, hitting the home islands, shortages of high-grade aluminum and steel, and the forced dispersal of production into small shops, all cut into output, and worse, into uniformity. Factories that had once turned out well-finished carrier fighters were now trying to assemble aircraft under bombing threat with substitute materials and with transport lines under submarine pressure. Even when an airframe was completed, it might not reach a frontline base with a full set of parts and with enough aviation gasoline to be flown regularly. That meant the limiting factor was no longer how far can a Zero fly, but how many serviceable aircraft can Japan actually put into the air in early 1945. As the U.S. moved toward Iwo Jima in February 1945 and continued pounding the home islands from carriers, this asymmetry showed on every raid. U.S. carriers could launch large fighter and strike packages, recover them, repair the aircraft on board using standardized Grumman components, and launch again the next day because the engineering and the logistics had been aligned. You do not need to claim a fixed 3 sorties per aircraft per day to tell the truth here. What mattered is that the Navy could sustain a high repeatable tempo because Hellcats were designed to be maintained at sea. That is exactly what Japanese units could not do in 1945. They had fewer trained pilots, fewer flyable aircraft, thinner fuel stocks, and repair shops trying to make mismatched or improvised parts work on lightly built airframes. Japanese commanders and aircrews by then were watching U.S. carrier groups reappear over and over with fighter cover intact, while their own aircraft strength declined after every contact. Losses in 1942-43 had already removed the best pilots. Accelerated training in 1944-45 produced crews who could not get enough flying hours because fuel was being rationed. Putting those pilots into aging or hastily built aircraft that lacked fully standardized spares made the problem worse. A damaged Japanese fighter at a forward base in 1945 often meant a grounded aircraft. A damaged U.S. Hellcat usually meant a repair and a return to service. This is the core of your title. By early 1945, the outcome was not being decided by the Zero's original long range, nor by individual pilot skill of the 1941-42 era, but by who still had an industrially supported, carrier-ready, repair-friendly fighter in numbers. Grumman and the U.S. Navy had that one design philosophy, 2 production streams, Grumman and Eastern Navy-wide standards for parts, and a logistics chain able to deliver them forward. Japan no longer did. So in 1945, when U.S. carriers were striking near the home islands and covering the Iwo Jima operation, Japanese factories could not match Grumman, and the ironworks' reliability is what finished the attrition war in the air. August 1945 closed a war in which the outcome in the air had been decided long before the surrender. By the time Japan accepted Allied terms, U.S. fast carrier forces had proved that a fighter built for carrier abuse, for rapid repair, and for standardized supply could stay in the fight year after year. The Grumman F-6F Hellcat was the clearest expression of that idea. It had the rugged landing gear, the self-sealing tanks, and the armor that pilots talk about, but its real power was that the Navy could get the same parts for it in quantity anywhere the fleet operated. A Hellcat that came back with battle or weather damage could be refitted on the ship using the spares the logistics chain had already pushed forward. That kept availability high across campaigns from 1943 through 1945, and meant that even in the final strikes against the home islands, carriers could still put up full-strength fighter covers. Japan could not do that in 1945. The aircraft industry that had produced the A6M Zero at the start of the war had been bombed, starved of materials, and broken into small, dispersed workshops. That move saved some tooling from outright destruction, but it also destroyed efficiency and standardization. Output was lower, parts were less uniform, and shipping them out to operational airfields was far harder because fuel and transport were tight. On top of that, aviation gasoline was so scarce that many air units could not even fly the hours needed to keep pilots current, let alone to run a hard operational tempo. So the theoretical advantages that made sense in 1941, a light fighter with excellent range for a carrier type flown by highly trained pilots, no longer mattered in 1945 because Japan could not field enough serviceable aircraft or pilots to use them. U.S. carriers, by contrast, were ending the war with depth. Grumman, in Bethpage and Eastern Aircraft under General Motors had already delivered Hellcats in five-figure numbers. More important than the raw total was that every one of those airframes was built to the same Navy standards, supported by the same manuals, and intended to be fixed at sea by Navy crews. That is exactly what the Navy had been doing since the Solomons recover aircraft repair to return to the flight schedule. In 1945, when carrier groups hit targets in the home islands, they were doing it with an air arm that still had its maintenance model intact. You do not have to insist that every Hellcat flew 3 times a day in August 1945 to make the point. The point is that the U.S. system still could have done high repeatable sorties because the aircraft and the supply were there. Japan's system could not. From the Japanese side, the picture was stark. Airfields that once turned around, Zeros now had aircraft sitting for lack of the right part, or for lack of fuel, or for lack of a fully trained pilot. Dispersed production had produced airframes that were harder to keep in frontline condition. Training had been shortened so much that many young aviators had almost no chance against experienced U.S. carrier pilots flying a forgiving, well-protected fighter. Every Japanese loss at that stage of the war was permanent. American losses even late in the war could be absorbed because the aircraft could be repaired or replaced, and the fleet logistics system was still functioning. That is exactly what your title says. Japanese factories couldn't match Grumman. Ironworks' reliability crushed attrition is not a claim about a single battle. It is the verdict of the whole Pacific Air War when you look at the end state in 1945. Japan started with a brilliant, lightweight, hand-finished fighter and elite crews. But when the war turned into a long oceanic attrition contest, the side that had factory-standard airframes, interchangeable parts manuals in every squadron, and ships full of spares won. Grumman designed for that reality. Japanese industry by 1945 could no longer even supply the basics. So the final picture in August 1945, American carriers still able to operate Japanese air power effectively gone, is the clearest proof that Ironworks' reliability, backed by U.S. industrial depth, is what finished the fight.